when convergence in probability includes the following. So if you have x1, x2, xn, we say that this xn converges in probability to a random variable x if probability modulus of xn minus x is less than epsilon. That means xn and x are closure. This must go to, so this is a function of n, right? Because it's a probability and it depends upon n. The n is varying. This must go to, as n tends to infinity. This must go to
One.
1. Yeah. Equivalently, you can also write that probability xn minus x, it's for all epsilon greater than 0. It's greater than epsilon or greater than equal to epsilon as n tends to infinity must go to 0. That means it's becoming larger. I'm sorry for the color, it's not matching, but yeah, I hope you understood that. So these are two equivalent facts, okay? Number one, this and this. So last day, the Virgo sir has done mostly about, I think he has done properties like properties of improbability convergence, like things like this. Like what happens when two improbable convents are added and a certain relationship between, I mean more about a certain relationship between what happens when he proved it. In fact, that's really good. What happens when the algebra of the improbability convergence and the invariance of the improbability convergence, okay? Like if xn converges to x and g of xn converges to g of x in probability, and he did some examples, right? So also, as I can see, he has done things like the connection point between in law probability, like in distribution and in probability of convergence, right? Where like that's the important point. But he also done a theorem, okay, about the variance and the expectation. Will prove that idea, and we'll see how to solve problems. Okay, today's class is mostly about problem solving. So before I move on, I should tell you about, as you can see in the last class, we have seen that if x1, x2, xn are IID some distribution. Then we have seen that in xn bar minus the corresponding mu, if they have a mu and sigma square, both of them. So if some distribution dot mu, or no, yeah, some distribution dot mu comma sigma square, then this converges in distribution to normal on the continuity points. So can we say something stronger? So, or maybe what is the corresponding convergence in probability? Because there's a different type of convergence, they have a relationship. So convergence in probability if xn converges to x. So yeah, let's understand this. So WLLN says that xn bar converges in probability to mu. Okay, xn bar converges in probability to mu. Okay. Now the theorem is that if xn converges in probability to x, sorry, in distribution, sorry, in probability to x, it implies that I mean, this is a result, but you don't have to remember the result. I will tell you what to remember. It converges in distribution to x. Also, you can say any sequence, if a normal real number sequence converges in a, that's equivalent to saying that it all converges in probability to a. If any sequence converges to a, that is equivalent to saying that any sequence, if you remember, any real constant is a random variable, okay, with zero randomness. So that converges in probability a. So we can say a and xn converges in probability to ax by the properties, okay, that we have done last time. So from here you can understand that, so this is a thing we're assuming, and from this we know that, so you can understand in some sense that also you have done last day this result, that if xn converges in distribution to a constant c, it implies that xn converges in probability to a constant. So from central limit theorem, you know that xn minus mu by sigma by root n converges in distribution to normal 0, 1. Sigma by root n converges in distribution also to 0, also probability both. Okay, so it's the sequence of natural numbers. Sigma is positive, so 1 by root n goes to 0. So sigma by root n converges to 0. It's a distribution and both probability to 0. Okay, so xn bar. So therefore, when you multiply this two, this must converges in distribution to 0. So there are results like that. I'm just trying to make you understand the idea. So the result called Slutsky's theorem. You must have learned this in your. So we are not doing this as of now, but I'm just telling you the ideas, okay? By combining this, we can get to here. So, and now, since this converges in distribution to 0, it implies that it converges in distribution to in probability to 0. And also it therefore it implies extreme converges in probability to mu. Okay. So core idea is this, but all these theorems I'm not you have don't have to remember. Okay, that's not required for the examination purposes. But there are these theorems where they tell you about how in distribution convergence and in probability convergence are related to each other. Okay, some are called Sutsky theorem. So there are properties of in distribution convergence, properties of in probability convergence, and interaction of this and this. Okay, so the relationship, this is called like Slatsky's theorem and all this results. But you don't have to remember all these things, okay? But certain things you should remember. I'm just telling you. But this is the idea of the proof that why it's true. Okay. So we can multiply this, we can add this up certain things, and that's because when in distribution and convergence are going together. So essentially, the idea is that when since the central limit theorem is equivalently, I mean, giving rise to the in probability convergence, right, which is the strongest statement to a zero. So understand xn is going towards mu, it's around mu in probability, and in distribution is telling you know that you know that, okay, xn minus mu by sigma that going towards normal 0 1. So essentially xn is going towards mu, okay, in some sense. So I mean you can write that in a way that xn converges in distribution to normal mu comma sigma square by n, okay, xn bar. We can write in this sense. Essentially, xn goes to mu, but we cannot write this in distribution format. Okay, so xn is going around mu, behaving around mu. Okay, and since sigma square by n is going towards 0, so we can say it converges in probability to 0. But we will come to this again. So there are two ways to prove convergence in probability. Okay, so I will teach you those ways today. Usually the ways, three ways rather. Also, why convergence in probability is important in statistics is something called consistency, which is equivalent to convergence in probability. Okay, which is equivalent to convergence in probability. So you will see this is coming up again, and that consistency class will be all about convergence in probability. Okay, and revision and solving of problems of that. So that's the same thing. So it's a way of measuring that. I mean, an estimator is good. Cool. So now let's understand the three ways. Number one way. This is the ways to show convergence in probability. Okay. Number one is this WL. In many cases, you can express the expression as summation or mean, like you have seen gamma and point show, etc. In other cases, so you use the WLLN, okay, and then also you can use this WLLN and this properties like continuous function goes properties of convergence. In consistency, you will see there is an important theorem that maximum likely estimate some type of estimated convergence probability. So you can use this and this probability of convergence, okay. So let's say, for example, you know that xn bar converges in probability to mu. So you can easily write an xn bar square converges in probability to mu square. Okay, by the result that is done in the class, because x square is a continuous function g of. So therefore, you can use WLLN and combine with these properties of convergence. And the third is this x theorem is already done. I will prove it. Expectation variance theorem, or you can write Varex's theorem. What is the Varex's theorem? You have already done this. I will explain it again. So essentially, these are the three ways of doing it. And the fourth way is maximum likely estimate that is done in the for the consistency part. But some things you may not know. Some things are so it's. I mean, maybe the improbability question it will be included that statistics wala idea. So maybe it's a collaboration between the two. Okay, combination of the two. So maybe that all information can be also important. So, anyways, these three fundamental ways are there, okay? Show, and also the fourth is the basic first principle, definition. The definition, just compute the probability and then show its. But this is much more beautiful. This one is much more beautiful and challenging too. But understand one thing among this. So what are the methods? I will write it once again. I'm just telling you the methods that usually is done. Number one, we use WLLN or other known results. Okay, like we know something goes to some probability in probability, and we add it with some properties of convergence or algebra of inconvergent probability to get the result together. Okay, for example, xn square convergent probability to mu square, this type of results we combine these two. The second one is we use the Varex method. What is the Varex method? Varex theorem. It's already done. If xn, the expectation of xn, the mu n, converges in probability to mu, and the variance of xn converges in sigma n square, converges in 0. That means what? The xn is going, around mu with variance. So essentially, its xn is around xn bar, xn is around, sorry, it will be xn. Then we can say that. Now the proof is really simple. Oops, wait a minute. Anyways, leave it. This result. Oh, so the proof is very simple. It uses this Chebyshev inequality. So probability. I hope you can see this, or maybe not. It's a bit light. Let me take a different. I don't know. Yeah, probability xn minus mu less than epsilon. If you remember, or so Chebyshev inequality is greater than equal to epsilon, right? Is less than equal to variance of xn by sigma square, epsilon square. Now variance of xn is sigma square, which goes to 0, you know that. So therefore this goes to 0. So what do you get? You get that xn minus mu n converges in probability to 0. Okay, you can see that xn minus mu n take together minus 0 greater than epsilon. And you know that mu n converges in probability to 0. So therefore, adding this to, sorry, mu, adding this to, you get xn minus xn converges in probability to mu by using the properties of improbability convergence.